What's up, everyone? Welcome back. Patrick here. Moving on to the next question in the rate of change unit test. So in this particular question, we have to find the instantaneous rate of change at an x value of 3 for these two functions here. And for both functions, we're going to have to use different methods. So starting off with part A, we got f of x equals the square root of 2x plus 5. And for this particular function, I'm going to use the centered interval method, and then for part B we'll do the preceding and following interval method. So actually, just to do a quick review on that, so if I show this on a number line, so we're finding the instantaneous rate of change at this x value of 3. And if you remember the centered interval method, what we do is we pick a very close point to the left of 3. So let's say it's going to be like 2.99 we'll use, and then to the right of 3. So let's use 3.01. And then what's going to happen is we're basically just going to find the average rate of change between these 2 points, right? The 3.01 and the 2.99. And that's going to give us a good approximation for the slope of the tangent at that x value of 3, because we're finding the slope between two very close points. So that's how the centered interval method is going to work, and that's what I'm going to do for part A. Now, to illustrate for part B, what I'm going to do in part B is I'm going to find the average rate of change for the preceding interval, so between 2.99 and 3, and then for the following interval, between 3.01 and 3. So in that case, we're going to do two average rate of change calculations, and then we're going to average them out, right? We're going to add our results divided by 2, and that's going to be another way to get an approximation for the instantaneous rate of change at an x value of 3. All right, so just a quick review and kind of a visual way to show how both of these methods are going to work. So yeah, like we mentioned, let's find f of 2.99 and then f of 3.01, right? So you're just going to plug in these two x values into this function. And so after plugging them in, these are the y values you're going to get. And so now we find the average rate of change, right, between these 2 points. So it's basically going to be f of 3.01 minus f of 2.99. So let's put the general format here, and then you're subtracting the x values in the denominator, right? So f of 3.01, it says 3.31963 minus f of 2.99, 3.3136 over 3.01 minus 2.99, and when you do this calculation, you would get approximately 0.3015. All right, so that right there is going to be the approximation for the instantaneous rate of change at an x value of 3, and the way we did it was with the centered interval method. Moving on to part B, next function, we got f of x equals 4 to the power of x minus 3. So again, different method for this one. We're going to use the preceding and following interval method. So there's going to be a little bit more calculations with this one. So we have to get 3 values, right? So just let's bring back this number line here because it's just easier to illustrate. So I got to find the value of this function, or the y value, at these 3 x values, right? Because we're going to be using them in our calculation, all 3 of them. So in this case, we got to find 3 points. And so plugging everything in, these are the corresponding y values that we would get from this function. So let's do these 2 intervals in different colors so you can see what's happening. So again, finding the average rate of change between these 2 close points. So what would we do? We would do f of 3 minus f of 2.99 all over 3 minus 2.99, like that. And then for the next interval, for the following interval here, we're going to do f of 3.01 minus f of 3. So again, in the numerators, using these y values that we got, over 3.01 minus 3. And so plugging in all of these values, these are the 2 rates of change, average rates of change that we get on the preceding interval and the following interval. And then what we have to do to get the approximation of the instantaneous rate of change is we have to average these, right? So what we would do is we would basically add these up and then divide by 2. So we'd end up with approximately 88.73. So that would be the answer for part B. That would be the instantaneous rate of change at an x value of 3. And that is the end of the video. Hopefully you enjoyed that. If you want to find more videos like this, you can go to my website, allthingsmathematics.com. Over there, all my courses are organized for both high school and university. All the videos are organized by chapter. Also, if you have any questions, you can hit me up. My contact details are also on the website. Enjoy your day, and I'll catch you in the next one. Peace out.